Hello everyone, welcome to the session on binomial distributions. I am Prasanna. What are binomial distributions and where and why do we use that? Let us consider a problem statement before going deep into the binomial distribution concept. Let's say there is a branded automobile company and they have released some they have released some different cars into the market and you would like to select the best product out of it based on the customer reviews. Let's say, for example, the car one has totally 10 reviews and all those 10 reviews are positive. And you have car 2, 60 reviews and out of which 58 are positive reviews and 2 are negative reviews. So the success rate is 96%. The car 3 has 250 reviews and here you have more number of reviews, but the 230 is the positive reviews and 20 is the negative is just 92%. Of course, by looking into the first case, it is having 100% possibility that all are positive reviews, but it is not realistic. So let's say there could be a negative review out of this 10, which makes it 9 positive and 1 negative review. Yeah. So this is somewhat not realistic. But how do we exactly select the best one? Here you have more number of reviews. Here you have average number of reviews, but still you are not sure which one to consider. So for this case, we would like to use the binomial distributions in order to determine the best product based on the customer reviews. So let's now fix the success rate to 96 and proceed with the probability. So we have seen here total number of positive outcome is 58, total number of reviews is 60, and 58 by 60 will give you 0.96 probability. Yeah. So the binomial distributions is nothing but the probability of probabilities. Yeah. So you have you have on the x-axis positive reviews and y-axis number of sample. Let's plot this and understand it better. So if we see here, we have selected 58 positive reviews and yeah, in this case. So let's take sample one. So this box here, what you see is defines sample one, which is 60 reviews and out of which 58 positive reviews. And sample 2, it can be, say for example, it's 56 reviews, positive reviews, and say for example the sample 3 can be 56 reviews and so on. So this is actually it's actually a random distribution. Just say for example in a sample 1 of 60 reviews, total 60 reviews, in sample 1 you will have 58 positive and 2 negative, and in sample 2 it can be this 59 or 60, it can be anything. So it's like it's just for our initial understanding, but to see this x-axis denotes the samples. Yeah. So let's say for example it takes many samples to determine the best outcome of this. So this x-axis would be unrealistic in this way, and let's make it as percentage of samples. So you have, say for example, in 1% of samples there would be a combination of all this combination of these many number of positive reviews. So it can be 54, 53, etc. so on. So 2 percentage, 3 percentage, 5 percentage will have this, and then 10 percentage, let's say for example, cannot have more number of 53 positive reviews, etc. So it's Actually, some hundreds and thousands of samples of 60 reviews you have to take in order to determine this. So this above graph is not realistic because in a sample of one, you will have say 58 reviews, it can be etc. So just for our understanding, I have plotted this as directly as sample count, but this below graph shows exactly the possibilities, realistic possibility percentage of samples, and you can see the distribution. We have considered success rate of 96%. With that success rate, you have got a curve like this, so the distribution like this, with the 58 positive reviews as the maximum, and then you have also 57, 59, etc., etc. Yeah. So this 26.53 percentage is it would be the best possible outcome, say percentage of samples that will have the best customer rating. So this 26.5 percentage of the samples will have the best customer rating of 58. So let's let us um, this is actually determined when you have to have hundreds and thousands of samples. So the formula to calculate this percentage is given here. So it's given by the formula NCXK multiplied by success rate, which is P power X, which is the number of positive reviews in this case, and 1 minus P power N minus K. So N is the number of trials and K is the possible outcomes. So this can be used to differentiate between different types of binomial distribution. Yeah, that will be discussed in separate video. And in this case, we have positive customer review and negative customer review. Therefore, there are two possible outcomes. And as you mentioned, the success rate is fixed to 0.96. And so let's now calculate the percentage. So n factorial by n minus x factorial into n factorial, and substituting these values, will be arriving at 26.53 percentage of samples will give out the maximum positive rating use of 58. Of course, it's not the it's of course it's the best one, and this much of samples is needed to determine it. Yeah, so this is this distribution of data that you see is nothing but the binomial distribution. So it helps to determine the best product from the available customer reviews. Thank you for listening.